In lesson 6.6, we're going to use triangle proportionality theorems in proofs and to solve problems. First theorem we'll look at is theorem 6.4 on triangle proportionality. It says if a line parallel to one side of a triangle intersects the other two sides, then it divides those two sides proportionally. So as long as I know that TU is parallel to QS, then I can state that RT is to TQ as RU is to US. We also have the converse of that. If I can show that the sides are divided proportionally by a segment joining two sides, then I know that that segment is parallel to the third side. So this is simply the converse of theorem 6.4. So in this diagram, we are shown that QS is parallel to UT. We know that RS is 4, that ST is 6, that QU is 9, and we're looking for RQ. So all we really have to do is set up our proportion. Since we already know that we have parallel lines, plug in our numbers and simply solve that equation. 9 times 4 is 36, then we divide by 6 and get 6. So QR was 6. Theorem 6.4 and 6.5 imply these. The contrapositive. If those sides are not divided proportionally, then the lines are not parallel, and if they're not parallel, then the lines are not divided proportionally. So whenever you have the conditional statement being true, then we know our contrapositive is also true. And we can use this to solve some problems also. On this shoe rack, we've got that AB is 33 centimeters. I believe I'll go ahead and label that. We know that BC is 27. CD, this part up here, is 44. And DE is 25. So we want to show that this shelf is not parallel. So BD is not parallel to AE. So the only thing we have to do here is set up our proportions and see if they are congruent to one another, and since they're not, then those lines cannot be parallel. Find the length of XY. Now what we have is that they are parallel here. So since they are parallel, and this is a guided practice, you should try to work this by yourself before you watch me explain it. If they are parallel, then we know that the sides are set up proportionally. So if I do 44 is to 35 as 36 is to X, and solve for X, that fraction reduces to 315 over 11. Determine whether or not they're parallel. Well, I decide if they're parallel by setting up my proportion and seeing if they are congruent, so are equal to one another. 90 is to 50 as 72 is to 40. And when you cross multiply, you will see that you get 3,600 for both. 90 times 40 is 3,600, and 72 times 50 is also 3,600. Therefore, those two are parallel. Theorem 6.6. It says if I have three parallel lines, then they divide the transversals that cut them proportionally. So the UW is to WY the same way VX is to XZ. Let's see how we can use that. Well, first let's look at this theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the other two sides. In other words, when I divide this angle, then segment AD here is to segment DB as the side that corresponds to that side is to the side that corresponds to DB. So when we look at a situation here, I've got Main Street, 2nd Street, and South Main. I'm given some information like the distance between main and second is 120 if you're going along this road from F to G, but it's 150 if you're going along from E to D. So they're not the same. However, I notice that I have 3 congruent corresponding angles of lines cut by a transversal. That means that these lines are parallel, and since those lines are parallel, I can set up some proportions. The corresponding angles are congruent, so FE, GD, and HC are parallel, and so I can say that I can find GH, which is this segment here. I can find GH by saying that GH is to the 300 as 120 is to the 150. I could have set it up other ways, but I found that GH is 240. Once I know that GH is 240, then HF, which is the distance between main and south, is 120 plus 240, or 360. So there's 360 yards from Main Street to South Main Street. In the diagram here, it says to use the given side lengths to find the length of RS. So what I need to do is find this X here. Remember what it said is this part is to here, so QR is to QP, as RS is to PS. Now when I set that up, I've got to think, what is RQ equal to? If RS is X, if this whole thing is 15, then RQ is 15, the whole thing minus the X. So I can now set up my proportion. So I have that RQ is 15 minus X is to X. This portion is to this, as 7 is to 13. When I find my cross product and then solve the equation, I get that X is 9.75. So RS is 9.75. So here's some for you to try. The fact that I have all 3 lines are perpendicular to the same line, I know that they are parallel, so that sets me up proportional sides. You could write these proportions in many ways, but we come out with 19.2. I do want to show you that we can do it in several ways. I could say that 16 is to X as 15 is to 18. So the 2 parts of the transversals proportional would give me 19.2. I also could do it where this segment is to the segment that is 16 is to the one that is 15, as X is to 18, because notice when I do my cross products, I'm going to get the same thing both ways. So you have options. It depends on how you see the problem. In this one, what we've got is a right angle here, and this segment is 4 and this segment is 4, and so if these are proportional, that's going to make this segment 4 square roots of 2.